Now that we've got the S1 scores done, letter grade we will do in the tab number 3. Okay, so we're going to pause it on this data and we're going to tab number 2 to teach you relative and absolute references. Okay, and better to be explained with a demo example here. Okay, BMI. BMI is defined as the weight divided by square of the height. Okay, that means that if your weight increases and assuming that your height stays the same, okay, we assume our height stays the same for most of our adult life, so but our weight can vary. As your weight gets higher, your BMI gets higher. Your weight gets lower, your BMI gets lower. So you're either underweight, overweight, and it is in relation to your height. Okay, so 60 kilos would be heavy if you are very short, but 60 kilos will be light if you are very tall, and so on. So the BMI corrects that relative to your weight, relative to your height. Okay, so let's do some calculations here. For someone whose height is 1.5, okay, 150 cm, in this case we want it, the BMI, it has to be in meters, 1.5. Okay, and the person who weighs 40 kilos with 1.5 height, who weighs 40 kilos, will have a certain BMI. And what will happen to that BMI if they would be weighing 100 kilos here? Okay, so let's do the BMI calculation here. So begin with the equal sign. We're going to start with the weight. I'm going to click the weight over here, divided by the height square. The height is over here. Height power. Okay, the power sign, you can find it above the 6 on your keyboard. Shift 6, it will get you this caret sign. Okay, so weight over weight in the C7, column C, row 7, and the height is found in D6, okay, column D, row 6. Okay, so our first one is correct, and ideally what you want to do is to be able to generate this down to the 100 kilos, but you realize that there's some mess going on here. Something is wrong with our formula. Okay, so we're going to make some minor tweaks. Let's have a look what went wrong by clicking our second box. Now, activating this, you find that the weight of 45 kilo, yes, C8 is correct, but now the height, which is supposed to stay 1.5, is found in the D6 cell. What happens, Excel has moved it down to D7, and in the next column is move it down to D8, and so on. So we don't want this to run, you know, D6, D7, D8. We want it to stay at D6 as we move down the formula. Okay, so how do we get Excel to fix this box at D6? Here's how to do that. If you click on the left of the 6, what we're going to do is to put a dollar sign, a dollar sign, shift 4, that's your dollar sign. We're going to lock the row 6. Okay, so by putting dollar sign, it will stay at D6. Let me repeat that. Okay, so let's check it. So if I look at the second formula, 45 kilos C8 divided by D6 square. Okay, it did not run to D7 because I've locked it using the dollar sign. Okay, we look further down to, let's say here, it's still at D6. Okay, even though the weight has moved down the rows, but the height has stayed at D6. Okay, so that is how you do, that's called an absolute cell referencing. That means instead of moving as the rows go down, and Excel has actually locked it there, okay, using the dollar sign. Okay, what we're going to do next is, once we've got the BMI for all these first height 1.5, we also want to be able to drag this formula to fill in the rest. Okay, so what that means is that I've highlighted for 1.5. Let me just make that smaller. Okay, so once we got the first column, what we want to do is to be able to drag this to the right and fill in for everyone. Okay, but it will still require some tweaks now, because not everything is correct. Let's look at the second one here. Okay, so you notice that for a person of height 1.52, you find that the weight, instead of taking 40 kilos, okay, the weight has shifted and taking now, the weight should be in C7, but now when we move one column to the right, instead of C7 it's gone to D7 and so on, and down here E7, F7 and so on. It's not taking the weight, it's actually taking the cell to the left. Okay, we don't want that, so we want it to lock. Okay, we want the first guy to lock at C7 and not move. Okay, how we lock that is we move our cursor to in front of the C, to the left of the C, and put a dollar sign. Okay, so we want to lock the column C. Okay, so let me fix that for the first box, and let's regenerate this down. Okay, regenerate the first row, first column again, and then drag it across to fill in the whole table. Okay, and let's check it now. Okay, so C7 is the weight, E6 is the height. Okay, and so on. So do some random checks to make sure that it's selecting these two boxes. Okay, and once again, let me show you the first formula that we did, that from which we generated the whole table. So what we did is, for the weight, okay, the weight, which is this C column, what we done is to put the dollar on the C so that the column C doesn't move, but it's allowed, the row is allowed to move because we want to see 40 kilo, 45, 50 and so on. Okay, so just lock the C, don't lock the 7 for weight. And then for height is at D6. Okay, we want the height to lock in the row 6. Okay, heights are all sitting on the row 6, but we want it such that the next person will be E6, F6, G6 and so on. So we don't lock the column, we only lock the row number. Okay, so learning which one to lock is important, which one you want to allow to Excel to shift versus which one you want Excel to lock it down. Okay, so that locking column or rows down is called absolute cell referencing.